For the last 50 years, our world has been built on this simple, predictable promise. Computers just keep getting faster, smaller, and way more powerful year after year. But that promise? It's about to be broken. We are literally about to hit a wall built by the laws of physics themselves. So, what comes next? Well, the answer isn't just a better computer chip, it's a whole new kind of reality, one that's built at the atomic scale. Let's dive in and see how.
So, here's how we're going to break it all down in this explainer. First, we've got to understand the problem, what I'm calling the Great Silicon Ceiling. Then we'll leap into the seriously strange solution, the quantum realm. After that, we'll see how nanotechnology is the key to actually building it all. Then, the really exciting part, how this unleashes superintelligent AI. And finally, we'll have to grapple with both the incredible promise and the very real peril of this new quantum future.
All right, Section 1. For decades, one simple principle has powered pretty much all of our tech progress. It's a rule that's been so reliable it almost felt like a law of nature. But as we're about to see, that engine is, well, it's about to hit a dead end.
Just look at this journey. It's the story of Moore's Law in action. We went from a couple thousand transistors back in 1971 to 50 billion in a single chip today. That relentless doubling has fueled everything, from the internet to the phone in your pocket. But see the end of that timeline? 2025. We're hitting the physical limit. The road doesn't just get steeper, it stops. We just can't shrink the parts anymore without completely breaking the rules of physics.
And that right there is the key. You've got to understand this isn't an economic issue or some engineering challenge we can just innovate our way out of. No, this is a hard stop. It's dictated by the fundamental rules of the universe.
So why is it a hard stop? Well, it's all because of this truly bizarre phenomenon called quantum tunneling. So imagine the little pathways on a computer chip are like lanes on a highway. We've made them so incredibly tiny, so narrow, that the cars, which are the electrons, they just start phasing right through the solid walls into other lanes. It creates total chaos, all kinds of errors, and a ridiculous amount of heat. I mean, we're talking about components that are just a handful of atoms wide. There is simply no more room to build reliable switches the old-fashioned way.
Okay, so if the problem is that quantum physics is breaking our computers, what if the solution is to just embrace those weird quantum rules? What if we build computers that run on them? That's our leap into the quantum realm.
To really get the scale of this leap, just look at this comparison. A classical bit, the foundation of every computer today, it's basically a light switch. It's either on or off, a 0 or a 1. Simple. But a quantum bit, or qubit, it's on a whole other level. Thanks to a wild property called superposition, it can be a 0, a 1, or both at the exact same time. Think of it like a spinning coin holding all the possibilities at once, right up until the moment you look at it.
But believe me, it gets even weirder. So weird that Einstein himself was totally baffled by it. He famously called this next concept spooky action at a distance.
And that spooky action is entanglement. So imagine you have two dancers, and they are perfectly synchronized, even if they're on opposite sides of the world. The instant one of them strikes a pose, with absolute certainty, the exact pose of the other one. Entangled qubits are linked just like that, creating this powerful, interconnected web where changing just one can influence the whole system, instantly.
So, what does all this strange new logic actually get us? Well, this number is the answer. It's so big it's almost meaningless. With just 300 of these interconnected qubits, you can represent more possible states than there are atoms in the entire known universe. This isn't just about more power. It's about plugging into a completely different and vastly more complex computational reality.
Okay, so we've got this mind-bending theory, but how in the world do you actually build a machine that can control all this spooky action? Well, that brings us to Section 3, where nanotechnology becomes the master architect of this new quantum age.
Now here is the single biggest challenge. That powerful quantum state, that spinning coin, it's unbelievably delicate. I mean, the slightest vibration, a tiny shift in temperature, and poof, the whole system just collapses back into a boring old classical state. It's called decoherence, and it happens in a flash. So protecting a qubit from all this environmental noise is the #1 engineering problem we have to solve.
And to solve it, we basically have to build the quietest rooms in the entire universe for these qubits, and Nanotech gives us the tools to do it. We're talking about crafting parts with atomic-level precision. using flawless synthetic diamonds to literally shield qubits, and building tiny mirrored cavities to trap and protect single particles of light. It's the ultimate feat of delicate, microscopic engineering.
But here's where it gets really, really clever. Building these things one atom at a time would be impossible, right? So the truly revolutionary part is that we can get nature to do it for us. Using things like DNA origami, we create a kind of scaffold, and then we add these nanoparticles that are programmed to just snap into place all on their own. It's like having Lego bricks that know exactly where they're supposed to go to build a skyscraper, all by themselves. It's incredible. So, we have the theory, and now we have the tools to build it. But for what? What's the killer app? Well, Section 4 is where we get to the main event, giving artificial intelligence the quantum-powered brain it's been waiting for.
Today's AI it's amazing. But as you can see here, it's hitting its own set of walls. The amount of energy it takes to train a model like GPT-4 is just astronomical and unsustainable. It still struggles with truly complex problems, and it's held back by something called the von Neumann bottleneck, which is basically a traffic jam where the processor is always waiting for data. This makes it way too slow for things like accurately simulating a living brain in real time.
And this number right here, this captures the quantum solution. For some really critical problems, like simulating the complex chemistry that helps us discover new drugs, a quantum computer isn't just a little bit faster. It is 100 million times faster. This isn't just an upgrade. This is a completely different class of machine.
So with this kind of advantage, AI can be trained exponentially faster. Hybrid algorithms can use these quantum shortcuts to find better answers and just crush problems. But maybe most importantly, it unlocks the ability to simulate biological systems with almost perfect accuracy, moving us from just making crude guesses to creating true digital twins of reality. Okay, let's zoom out to our final section. Because a technology this powerful isn't just going to change our gadgets, it's going to reshape our world. And wielding that power comes with enormous responsibility. We really need to look at both the incredible promise and the potential peril.
And this gives you a little glimpse of that future. We're talking about discovering life-saving drugs in months, not decades. Designing brand new materials, atom by atom, with properties we can only dream of today. And as you see here, it paves the road to true artificial general intelligence, and maybe even the augmentation of our own biology.
But let's take cybersecurity. This new power is a perfect double-edged sword. It simultaneously creates the ultimate weapon for breaking every code in existence and the ultimate shield for protecting them. So the threat is this. A powerful quantum computer, using a special recipe called Shor's algorithm, could shatter the encryption that protects literally everything. Your bank account, government secrets, you name it. But the shield is that the same physics allows us to create totally new kinds of encryption that are, by the laws of nature, fundamentally unbreakable. The race is on, right now, to build that shield before the sword is fully forged. And here, we get to the most profound implication of all. The very same nano-quantum tech could eventually create a direct interface between our brains and this new kind of computing, potentially boosting our own cognitive abilities by 1,000 times. We are moving from augmenting our reality to augmenting our humanity itself. And that brings us to our final and maybe most important question. This technology isn't just about building faster computers, it's about learning to simulate reality itself. So when we can finally build a machine that perfectly simulates a human brain, we're going to have to ask ourselves, what does it truly mean to be human?